My dear not geometry, but honors calculus students, peace and grace be with you. This is a video I decided to make to help you with your preparation for the quiz, and I trust God will enlighten you and enlighten me as I make this and as you listen to it, so you can have some really deep insight into the questions and the concepts that you need in order to just do your best for Him on this upcoming quiz. You'll recall that the concepts we're looking at are as follows. Uh, the derivative of e to the x is the same as e to the x, and what attribute of God does that remind you of? And needless to say, I'm sure you remember that He never changes. The derivative is a measure of how something is changing, and He's the same certainly yesterday, today, and forever. And so we find that e to the x is very, very symbolic of who He is. His faithfulness is the same. The sun rises at the same time each day because He's so faithful. And that's one. And then the other would be in terms of working out integrals using upper or lower sums, the number of intervals that you choose. So the question would be, what ensures that the integral is accurate? And I'm sure you know that also. That we've got to consider the infinitely large. And who is the most infinite that we know? And also we have got to consider the infinitesimally small. I find that very admirable that we have to consider God, and we also have to consider the ones who are, as it were, the least of the brethren, or even the very hairs of our head, He said, are counted. And that's an indication of how much He's thinking of us. In terms of the problems, here's one from page 338, number 8. I didn't give you this one, but I'd like you to look at it with me. Number 8, if you want to find an integral, as it says here, of x squared all over 3 minus x cubed, I'd like you to note very quickly that the degree of the denominator is 1 higher than the degree of the numerator. Therefore, if we set u equal to 3 minus x cubed, when we do the derivative in terms of du, it's going to be equal to x squared dx. Again, this being 1 degree higher than the numerator, when we do the derivative, we're going to get x squared dx. Then we'll be able to substitute also for x squared dx. So that's how you judge. If the degree were, let's say, x to the 4th in the numerator and x to the 5th in the denominator, and it's set up like this, you'd say, you know what, that 3 minus x to the 5th is a good candidate for a u substitution. And I can just hear Sam saying, you instead of me? No, it's Jesus who is substituted for you, and He's also substituted for me. So that's pretty good. All right, so that's what we do. You say u then is equal to 3 minus x cubed, so that du would be equal to negative 3x squared dx. Now bear in mind, we have to substitute for everything in x in terms of u. So we're going to have to substitute for x squared dx. And here it comes, x squared dx. I'm sure you can see this clearly. That's going to be equal to, when we divide both sides by the negative 3, not x cubed, sorry, x squared dx, is going to be equal to negative du over 3. So here comes the complete substitution now. 1 over u, and I'm sure you know what that integral is. And for x squared dx, we will put negative du over 3. And here we're going to make it very, very simple by keeping the constant on the outside and doing the integral of 1 over u du. And I can just hear Rachel shouting, LNU, LNU, ln u. It's exactly what it is, ln u. And let's not forget the most important part, it's being indefinite. It's a limitless aspect to it plus a constant. Back in terms of x, now it's be 1/3 natural log of 3 minus x cubed, because that's what u is, plus a constant, and that will be our answer for that one. Let's take a look at this one, which is a little bit more awkward. I don't think I gave you this, but I'd like you to be able to do these. This is the same page, 338, number 20. And here you see you got 1 over x, and beside the x downstairs is natural log to the x cubed. What I'd like you to see is that this factor here, natural log of x cubed, if we put u, well, we can do something with it. First of all, we can do something with it. And if you remember the properties of logarithms, you will remember that we can bring the exponent to the front. That's a power property here. So essentially we can write this as follows: the integral 1 over x, and by the power property this can be written as 3 ln x. That's with respect to x. And what I'd like you to see is we have 1 over x here. What does that bring to mind, 1 over x? Hope you're thinking that the derivative of ln x is 1 over x. So here's what I've got in mind: 1 over x dx. I will be able to substitute for that if I make u to be equal to ln x. That's a very, very skillful substitution there. You say, what's so skillful about that? Take a look. Du then will be equal to 1 over x dx. Isn't that neat? So 1 over x dx, which is a term I need to substitute for in terms of u, is simply du. So here's my complete substitution. I'm going to put it over here. Integral for this downstairs 3 ln x, it's going to be like this: 1 over 3 u, and then 1 over x ln x is simply going to be du. Oh, do you like that? Equals 1 over 3, again we've seen this before, 1 over u du, and this is the simplest thing for us to do, Jennifer, right? It's going to be 1/3 times the natural log of u plus our constant. We always have a constant companion, and I'm so glad he never leaves us, never forsakes us, always with us. Instead of u now, I'm going to substitute back the ln x. ln x plus a constant. So you said 1/3 ln x, sorry, ln of ln x plus c. You said, can we have an answer like that? I'm sure you can see it. There it is. That's the answer for that one. All right, let's take a look at a few others that I'm sure will be helpful. Take a look at this page. I gave you this one, page 399, number 19, 22, and 41. Here's number 19, and I'd like you to look at it carefully, even before we do anything. And as you can see, u substitution is very, very helpful to us. If you look at this at the denominator, and always be looking at that. The denominator 1 plus cosine x, if we put u equals that, when we do the derivative, the 1 will go to 0, and this will be negative sine x for the derivative. So we're going to have a sine x dx in the mix, so that we can substitute completely over from x to u. So here it comes. U is equal to 1 plus cosine x. So that du is equal to what? Negative. Not cosine, but sine. I was going to write cosine. Sine x dx. Okay? trust you're smiling because you say, oh, so sine x dx I can substitute over from x to u. Yes. So sine x dx is simply going to be equal to negative du. So as we substitute completely from x to u, we get 1 over, for 1 plus cosine x, I'm going to write u. And then for sine x dx, I'm simply going to write negative du. How do you like that? Okay. I can just see Jessica chuckling and whatever. Here we go. So negative on the outside then, integral 1 over u with respect to u. So this would be natural log of u plus a constant. Final answer here would be natural log of 1 plus cosine x plus a constant. Okay, you see the book keeping this in absolute value symbol for obvious reasons. All right, this one here, 22, I think I gave you that one. I think by now you'll be able to say, oh, if I put u equals ln x, I'm going to have 1 over x dx, and that's what I want. So here I'm going to put u equals ln x. So your substitution has got to be very, very skillful so that you can substitute over completely from x to u. Just like Jesus substituted himself completely for me and for you. He is our complete substitute. In fact, right now, when God looks at him at his right hand, he sees you. He sees me as perfect because he was such a perfect substitute. So if u is equal to ln x, I'd write du is equal to 1 over x dx. So now I can substitute for 1 over x dx. See, where have I seen that before? Right here, 1 over x dx, right here. So here comes a complete substitution over from x to u. It's going to be for ln u, simply going to be u, and 1 over x dx will simply be du. Do you like that? Simple integral, right? U squared. This time, plus c is the answer. And u is still ln x as we substitute back in terms of x plus a constant. Okay? That will be our answer for that one. And finally, I've got one to help you practice the exponential derivative, and I gave you this one. So in this one, we're going to do the u substitution, and this is for this one, we're finding y prime. And here we're going to be able to use the chain rule. And you might remember the song goes something like this. Dear of outer times dear of all inner, do the chain rule without a quiver. Dear of outer times dear of all inner, do the chain rule and be a winner. All right, so if I write it like this, e to the 2x plus e to the negative 2x, and this now would be to the 1/2. The derivative of the outer is going to be bringing the 1/2 forward. 1/2 of this whole thing, that's the outer. Knock this down 1, and then we'd have to do times the derivative of the inner, okay? Let's see if I can do it in maybe a couple steps here. So dear of outer would be 1/2 times e to the 2x plus e to the negative 2x to the negative 1/2. That's the outer, times dear of all inner. So the derivative of e to the 2x would be 2 e to the 2x plus derivative of e to the negative 2x would be negative, it should be a minus then, e to the negative 2x. Alright? So then, where is my 2? I forgot my 2. Minus, 2 e to the negative 2x. We could make that a little bit nicer, but this is the basic deal that we're looking at right here. We could of course bring it downstairs and make it look something like this. Let's factor out a 2. And we'd have e to the 2x minus e to the negative 2x upstairs. Downstairs, let me not forget this 2. I could put it over a 2 because of the 1/2 here. And then this would be the square root of e to the 2x plus e to the negative 2x. The 2's will destroy each other, and my answer will essentially be this right here. Alright, again we could make that nicer because this is to the 1/2 here and we could possibly bring it up, but I'm just going to leave it like that for now. Alright, if you brought it up, the book might have it this way because this is to the 1/2. If you brought it up, it would be e to the 2x minus e to the negative 2x will be the square root of that. Okay? So may God bless and keep you now. I look forward to seeing you tomorrow if you watch this today. And I trust you'll be ready to go. Bye-bye now.